Let's look at integrating logarithmic and exponential functions. Right? So let's look at the first one. Integral of minus 3x to the power of minus 1 dx. We can take out the constants, and x to the power of minus 1 can be written as 1 by x dx. So the straightforward way of figuring out the integral is to see what is that function. When we differentiate it, we get this, right? So we know when we integrate, when we differentiate natural log of x, we get 1 by x. So that would be natural log of x, right? But at the same time, we also know that natural log cannot be evaluated for negative quantities. So we put an absolute value for x, so that it becomes a positive number. And then plus c, that is a constant of integration. Okay, let's look at second one. Integral of 7 by x dx. Again, take out the constants. 1 by x dx. 7 natural log of x plus c. Okay, now integral of 3x to the power of minus 1 dx. This can be written as 3 integral of x dx. This is minus 1, so minus 1. Then this can be written as integral of 1 by x dx. So this becomes natural log of absolute value of x plus c. Okay, the fourth one, integral of minus 10 x to the power of minus 1 dx. This gives us minus 10 1 by x dx. So again, minus 10 natural log of absolute value of x plus c. 1 integral of 5 by x dx. This gives us 5 integral of 1 by x dx, which is equal to 5 natural log of absolute value of x plus c. Pretty straightforward. The simplest case would be integral of 1 by x dx, which we know is going to be natural log of absolute value of x plus c. Seventh one. Now, instead of giving it as a negative exponent, it might be given as 3 by x dx. So 3 integral of 1 by x dx. Okay, so this would be equal to 3 natural log of absolute value of x plus c. Okay, 8th one, integral of minus 3 by x dx. So again, minus 3 integral of 1 by x dx, which is nothing but minus 3 natural log of absolute value of x plus c. Ninth one, integral of minus 2x to the power of minus 1 dx, which is equal to minus 2 times 1 by x dx, which gives us minus 2 natural log of absolute value of x plus c. Okay, now let's change it a little bit. And integral of 4 e to the power of x dx. Okay, now here what will it be? It will be 4 is constant, so e to the power of x dx. And again, you need to ask the question, what do we differentiate to get e to the power of x? That is e to the power of x and plus c. Okay, 11th one, integral of minus 4 times 2 to the power of x dx. Now this is a little bit different. Remember, this can be written as minus, we can take it out. This can be written as 2 square times 2 to the power of x dx, which means we can write this as 2 to the power of x plus 2 dx. And now in this case, the result would be minus 2 to the power of x plus 2 as it is, and then in the denominator you will have natural log of 2, the base part, plus c. Now, how did we arrive at this? Right? So again, we need to look at verifying this, whether it is correct or not. And in the process, we will learn something. Now, let's look at this. If we differentiate this, we should get back this, right? So let's begin. Let's start off with 2 to the power of x plus 2 by natural log of, right? Let's say this is f. So now let's differentiate this. How do we differentiate this? Remember the trick that we saw in the previous sessions? Let's take exponentiate it and take the natural log of 2 to the power of x plus 2 by natural log of 2. This can be written as x plus 2 times natural log of 2 by natural log of 2. Till now we have not differentiated. We have just manipulated it. Now let's differentiate it. What do we get? E expression comes as it is first, and then we differentiate the exponent. 2, if we distribute it, we get x natural log of 2 and 2 natural log of 2. 2 natural log of 2 is 0 because it is a constant. So we need to differentiate x natural log of 2. So which gives us natural log of 2 divided by natural log of 2. This and this cancels, and we are left with e to the power of x plus 2 natural log of 2. Again, logarithm rules, e to the power of natural log of 2 to the power of x plus 2. We can take it back up. Now, e and natural log cancel. So we are left with 2 to the power of x plus 2, which can be again split into 2 to the power of 2 times 2 to the power of x, which is equal to 4 times 2 to the power of x. So we got back our previous, right? So the integral of this is this. Now let's look at the 12th one. The more you practice, the more you'll be able to do it instinctively. 4x to the power of minus 1 dx. Pretty straightforward. 1 by x dx, which is 4 natural log of x plus c. Okay, 13th one. Integral of minus e to the power of x dx is equal to minus e to the power of x dx. The integral of e to the power of x is e to the power of x itself plus c. Okay, 13th one. Integral of minus 4 e to the power of x dx. Minus 4 we can take it out, so e to the power of x dx, and minus 4 times e to the power of x is e to the power of x. So e to the power of x plus c. Okay, 14th one. Integral of minus 3 times 4 to the power of x dx. Okay, so minus 3 we can take it out, 4 to the power of x dx, and we have seen minus 3 times, this will be what? 4 to the power of x as it is, and in the denominator natural log of 4 plus c. And we have already proved this, right, by verifying the answer of the previous 11th problem. For practice, you could do this here. Verify that this answer is correct by taking this and differentiating it to get back this integral. Okay, 15th one. Integral of 3 times 5 to the power of x dx, which gives us 3 integral of 5 to the power of x dx. 3 times, this is going to be what? 5 to the power of x as it is, and then in the denominator natural log of 5. Remember, if it is a constant like this 5, we don't have to put the absolute value because it is understood that it is positive. But if it is x, then we have to put a absolute value. So plus c. 16th one, integral of minus 5 e to the power of x dx, which gives us minus 5 integral of e to the power of x dx minus 5 times e to the power of x as it is, and then natural log of e, right? If we strictly follow the pattern that we have been following, but then natural log and e cancel out each other because they are inverses of each other. So we are left with, if they cancel out, we are left with 1. So answer is minus 5 e to the power of x. Okay, 17th one. Integral of 4 times 3 to the power of x dx. 4 we can take it out. This becomes 3 to the power of x dx, which is equal to 4 times 3 to the power of x as it is divided by natural log of 3 plus c. 18th one, a pretty straightforward one, e to the power of x dx. Again, if you have to follow the same pattern, we would write it as e to the power of x as it is divided by natural log of e. Now, natural log and e cancel out each other. We are left with 1. E to the power of x plus the constant of integration. So that is logarithmic and exponential integration. We'll look at more complicated ones in a future session. That's it. Bye.